All right, let's just jump right in. Welcome to this explainer, where we are going to unpack the actual blueprint of the factory of the future. We're looking at a really comprehensive review today, one that synthesizes 130 incredibly complex academic sources into a clear visual roadmap for what we call Industry 4.0. There is a ton of noise out there right now about digital manufacturing, so today we're cutting straight through it.
Now, right off the bat, we've got to confront this massive reality gap. Check this out. A staggering 95.1% of the literature studies Industry 4.0 in a strictly laboratory setting. A totally minuscule 4.9% documents actual implementation in real industrial applications. So almost everyone is theorizing about the factory of the future, but practically no one has actually built it yet.
To figure out why this huge implementation gap exists, we first need to get on the same page about what these authors actually mean by this revolutionary shift. They define Industry 4.0 as flexible production systems that literally clone knowledge using algorithms. This allows the systems to become self-configurable, truly self-aware, and intelligent enough to make their own decisions. We're not just talking about robots doing repetitive, mindless tasks here. We are talking about systems that learn, adapt, and essentially run themselves.
Here is our roadmap for the breakdown today. First, decoding Industry 4.0. Second, the core design principles. Third, the tech powering smart factories. Fourth, the new human factor. And fifth, the reality for small and medium enterprises.
Let's start with Section 1, Decoding Industry 4.0 and Understanding the Scope of the Revolution.
When we zoom out and look at the massive scope of those 130 scientific sources, a few big things pop out. Heavy hitters like the Internet of Things, smart technology, and blockchain absolutely dominate the literature. But man, the conversation is incredibly fragmented. We're talking about dozens of subtopics from big data all the way to augmented reality. The ecosystem of a smart factory is just vast.
But when you're wading through all this data, it's absolutely crucial to distinguish between a system just being intelligent versus being truly smart. In this research, an intelligent system uses digitization just to collect data. But a smart factory? It actively exploits that data for autonomous production. It takes those numbers and actually uses them to automatically reconfigure itself and run the floor.
Moving right along to Section 2, the core design principles, the foundational rules of Industry 4.0. You see, a smart factory doesn't magically happen just because you bought some expensive software. It rests on these non-negotiable foundations. First, interconnection and connectivity. Literally everything must speak to everything else, which usually means 5G or advanced networks. Second, decentralized decision-making. The agents right there on the floor have to make real-time choices without waiting for a central server. Third, total information transparency. And fourth, interoperability, meaning totally different systems have to seamlessly swap data. To make sense of all that, the scientific community has established a unified taxonomy. By tracking how experts map out connectivity and transparency over time, they're building a standard blueprint. That way companies aren't just taking wild guesses when they try to implement this stuff.
Okay, now for the really fun stuff. Section 3, Tech Powering Smart Factories, the Enablers of the Future.
First up, we have cyber-physical systems, or CPS. Think of these as the central nervous system of the factory floor. They flawlessly integrate the physical world, the actual machines and conveyor belts, with the virtual world. Their whole purpose is to monitor and control physical processes in real time, instantly translating physical movement into digital data and vice versa. Next is the digital twin. Imagine having a living, breathing mirror of your physical machine running right on your laptop. That is a digital twin. It's this incredibly complex simulation that uses real-time sensor data to perfectly mimic its physical counterpart. You can run tests, hunt down bottlenecks, and simulate entire production runs without ever touching the real equipment. It is an absolute game changer for risk-free optimization.
And to protect all this highly sensitive data flying around, researchers are leaning heavily into blockchain. Yeah, well beyond just cryptocurrencies. Factories are using the decentralized power of blockchain to lock down security and trust. By using smart contracts, manufacturing systems can execute agreements and automate supply chain logistics the very second specific conditions are met.
Ultimately, building a smart factory is about connecting specific technological enablers, like cloud computing or 3D printing, directly to the manufacturing traits they produce, like agility and mass customization. It's basically a massive menu from which a fully realized smart manufacturing environment is built. Now, with all this autonomous tech managing itself, you're probably wondering, are humans becoming obsolete? Well, that brings us to Section 4,
the new human factor.
The research gives us a resounding no. I love this insight from the literature. It says, the human factor is the center of gravity of smart manufacturing systems, as they benefit from operators' experience by creating feedback loops. Sure, robots might take the highly repetitive jobs, absolutely. But human operators and their intuition, that remains the absolute center of gravity. That's how these digital systems actually learn and get better. But here's the catch, and this is what you really need to take away. The human role is shifting drastically. Workers have to master completely new professional competencies. Tomorrow's factory worker isn't just turning a wrench. They're navigating virtual and augmented reality to do maintenance. They're engaging in high-level, human-machine collaborative decision-making. We're making a huge leap from physical labor to advanced cognitive oversight.
Finally, Section 5, the reality for SMEs, bringing it back down to earth.
Remember that stat at the very beginning? Only about 5% of this is happening in real industrial environments. Why? Well, the literature points to a major culprit, the SME confusion risk. Small and medium businesses are confusing the constant buzzwords of Industry 4.0 with a desperate need to panic buy disconnected tech. They grab an IoT sensor here, a robot arm there, with zero unified strategy. Those disjointed investments don't make a smart factory. They just make a really expensive headache and totally unnecessary overhead.
To clear up this confusion, researchers are building out some seriously complex analytical and AI models like dynamic programming and advanced simulations just to optimize production planning. But right now, these models are deeply, deeply academic. Bridging the gap from high-level math to practical tools that a floor manager can actually use remains a massive hurdle.
So, how do we actually fix this? The authors highlight 3 critical steps to get those lab experiments onto the real-world factory floor. 1. Create clear conceptual frameworks specifically designed for SMEs. 2. Develop user-friendly quantitative models. And 3. Establish a universally standardized reference architecture, so businesses aren't constantly reinventing the wheel every time they try to upgrade.
Which brings us to the end of today's explainer. As we stand right on the edge of this massive industrial shift, integrating AI, digital twins, cyber-physical systems, it leaves us with one incredibly vital question to ponder about the future of our own workplaces. As the factory of the future becomes today's reality, is your industry preparing its people for the machines or just buying machines for the people? Thanks for joining me for this deep dive. Catch you next time.